Welcome back everybody. 4.3.5 Future Energy. And I do realize that you've watched a lot of videos in this module. Keep in mind that this is typically a 15-week course on campus with 3-hour meeting sessions. So this is really condensed into a shorter 8-week period. So I hope that you can digest all of the materials, and I will be keeping the Vimeo site up for quite a while to give you a chance to, after the course is over, to catch up. The idea of future energy is really interesting to me because it presents an optimistic view of the future where the investment of technology as part of our idea of reserves will create new forms of renewable energy that will be exponentially more powerful. So for example, IBM is working on a solar collector magnifier that will magnify the sun's rays and power by 2,000 times. So we're looking at an incredible amount of energy generated in a relatively small area in a very clean way. And this is sort of the trend that we're looking to as companies and individuals try to maximize their profit through self-interest, but also try to do the right thing and take care of future generations. Solar thermal is not really a future technology. It's actually in practice now. I'm going to talk a little bit about that for a few minutes. The general concept, and I'll get into the details, is really reflecting the sun's rays through hundreds of thousands of mirrors to a tower that has some thermal mass in it that can then generate electricity. So this is what they look like in the desert. They take up roughly a 2-mile area. Keep in mind that these are very far from the main electrical grid. So although they generate a lot of electricity, there's still a 10% transmission loss as the energy is moved to the grid. Doesn't mean that it's not a great opportunity. It's just wanted to keep in mind the limitations. So the power towers, also known as heliostat power plants, are there at the top of a tower, and then we have thousands of tracking mirrors called heliostats over 2 miles that will reflect the sun's rays to the top of that tower and concentrate that. The heliostat focus concentrated power receives all of that energy, and then there is molten salt that's stored in there, and that salt is heated to 1,000 degrees Fahrenheit or 538 centigrade. And what that leads to is a lot of thermal mass. 98% is stored as thermal efficiency and then pumped to a steam generator, which will eventually spin a turbine to generate electricity, which has been the standard system that we've looked at through most of these technologies, like hydro, for example. In comparison, so here the solar energy density for these kinds of technologies is 50 watts per meter squared. So for every square meter, which is not a very big space, we're getting 50 watts of power. If you compare that to solar hot water, for example, which we haven't even really covered yet, which is just solar hot water for domestic use, that's not really energy. That's just temperature that we can use, like geo-exchange. But PV panels get about 10 to 20% of that power, so 5 to 10 watts per meter squared. So like wind, we need vast amounts of area in order to generate the power that we need. And I covered biomass way back at the beginning, and that's really not very efficient compared to these types of systems. So that's just to give you a sense of how wonderful and amazing this solar thermal technology can be. And we should see more of this in the future. Spain has invested heavily in this, and the US has built a first couple plants. Some of the other kinds of future energy are tidal wave power. These are obviously ways to really harness the power of the moon, because the moon drives the tides. And some of the ways that this works is energy is measured per length, not per area, so as much as 40 kWs per meter. So 40 kWs is a very large number. So there's a huge potential for energy generation here. Some of the barriers are the same. The distance from where the energy is generated to where it can actually be used by humans is going to be an issue in terms of drop off of power, and certainly there's large technological issues here as well as regulatory issues of where these are located and how they would actually function. But pretty exciting opportunity when you think about energy from flows, which is what we've been talking about. This is energy that's just there. It's potential energy just waiting to be harvested by us as humans. It is difficult to capture this, and we've talked about that already. And we would need 3,700 kilometers to generate 1 kW of power per person, which is sort of a standard. So pretty exciting, but certainly a lot of barriers still exist to that. And of course, maintenance is a real issue. Now, you've all heard about fuel cell technology, and we've talked about cars that run on fuel cells. Bloombox is a new company, or Bloom Energy is a new company that's formed to develop something called the Bloombox, which is a relatively small box that sits outside of your house and can generate electricity through a fuel cell technology. The fuel cell technology, I'm not going to get into too much detail, but hydrogen fuel is channeled through the field flow plates to generate. That's basically, it's using hydrogen fuel, which is an invisible gas, highly flammable, hence some of the externalities that we worry about. But generally speaking, we can get a reaction between hydrogen and oxygen to generate a flow of energy that can be used not only to deliver energy or electricity to a building, but there's also a fair amount of waste heat that comes out of this that can be generated, also harvested, also to be used. So the balloon box is interesting because it's really a lower, it's still ridiculously expensive, but it's starting to become something that we can begin to see as a future energy, fuel cells. And then of course you've all heard about the idea of growing and harvesting power from algae, mostly to make a biofuel. So this would go back all the way back to the first set of slides we did on biomass energy or biofuels, which are really low-grade fuels, but if done in great quantities can be really good for the environment. And algae is really something that's not desirable in the natural environment in terms of humans, so this could be a real boon for the future of energy. So that's the end of this short video. I wanted to end our energy from flows on a high note. As I mentioned before, we're a little behind on the written content, so I want you to stick with the Vimeos. The next video we're going to be looking at 4.4, which is energy demand reduction. Thanks again for watching.